Hello guys, Cristiano here. I am a C programmer, learning all those things that I can. Hit the subscribe button, let a comment, that'll help so much the channel. All my videos will be in a fast mode with explanation. I'll reduce the time to be more precise. And we will face a lot of mistakes and debugs. Everything's calculated, or not. So don't be afraid. The link for all the source codes will be in the description. If you wanna follow, just get your copy. One of the problems I always face is when it comes to serialize and deserialize an object to JSON. This is something that in the other languages you can do effortlessly. In this video, I introduce the creation of a feature that I implement to make my life easier. It is a bit tedious, but it is less tedious when doing it from scratch. I built this feature on top of CJSON, so let's get started. We create a file to add a CJSON dependency to the project. In this case, it is quite interesting that I include the CJSON files themselves and not the library in the project. This feature could even be considered built-in. But for now, let's leave it as is. We created folders for JSON as well as its main files. I copied the source and the header for their directories. In the JSON header, I include some necessary headers and create a structure name mapper. Using a forward declaration, next I create a callback getNext, which receives an object void pointer and an index, returning a map. Returning a mapper, I create a enumeration to define CJSON types, object, array, int, double, float, and string. We then define the mapper, which has a token, data, size, type, and if it is an object, we can have an internal object. It also includes a number of fields and a function to get next, hidden in case of a list. Next, we create the actual context, which includes the JSON, the buffer size, and the type. Immediately following this, we create the args to allow the buffer parameterization. We create the basic functions, init, open, and close, and two additional functions to create an object and an array. Another function was created to add an element to the create object or array, receiving the type, token, and data. We also create a function for deserialization that receives a JSON, the map, and the number of fields. And finally, a function to convert the JSON to a string. We copy this to the source file, adding the includes, and paste the functions. Adjustments are made as usual. This boilerplate code is something that should be automated as it takes a small amount of time, but it becomes annoying after a while. In each function, we clear the context. In the open function, we only make assignments to the context. In the serialize create object function, we create an object and set its type to object. In the serialize create array function, we create an array and set its type to array. Moving to the serialize add function, we check if this type is valid. If it is, we add the accordingly with its type, whether it's an object or an array. We create a new function to perform the verification, which needs to be implemented. Its implementation, it's simple. If it is between the intervals, it returns true. Back to the implementation. We also need to implement add to object and add to array. In the add to object function, we check the type to add to the object, handling and adding depending on the type. For add to array, no special handling is needed, so we use fall through to add it directly. The heavy lifting of this library is in the deserialization. Here we perform several checks to ensure the arguments are valid. We then parse the JSON and check if it's valid. Next, we call deserialize items, passing the parsed JSON with the mapper and the fields. After completing the mapping, we delete the JSON root. Implementing deserialize items involves creating the prototype. For its implementation, we scan with a for loop based on the fields. We get the item and check if it is not null, then check if it is not an array. If it is an object, we recursively call the serialize items. We add another check to see if it is an array. If it is, we call the serialize array. If neither, it is a primitive. To implement the serialize array function, we create a variable for the index, get the JSON object based on the index, and get the fields. In the loop, we keep checking if the data is valid, if there are fields, and if getNext is implemented. We then get the mapper for the index, check if it is not invalid, and call the serialize items again. If there is no token, it's an array without the token. We free the mapper and get the next item in the array. Now, for the deserialize primitives function, we need to adjust the logic in the serialize array to return true if at least one item was deserialized. Returning to the serialize primitives, we check the type to handle filling the variable appropriately. Coping based on the type. For strings, if the data is larger, we consider the smaller value for copying with fmin. In the toString function, we get the string based on JSON in the context, check if the string is valid. and if its size is smaller than the internal buffer. We clear the buffer and copy the value. The JSON then references the buffer, and we free the string since you already have a copy. In the close function, we delete the internal JSON, concluding the implementation unless we find errors. We add an option to enable JSON and its compilation rules. We create a test folder and add it to the test rules and create a test compilation rule. The test is quite extensive. I test varied forms to see if the conditions were realistic and if something I could use. Let's go through it. We include the headers and create a person, object to another registry, and another registry that has person as the responsible and 2 children. Another object is for the address and another with an array of integers. I create a ruler map to the next person, which has a name and age, specifying the types. I allocate a mapper to return it, remembering that it will be deallocated internally. I use the same rule to implement the values. I create some functions to print the objects, ended up remembering to create another object, the owner, which has a person and an address. I adjust the names of print functions and create some functions to test the different types of JSON. The first test is for serializing the object. The second is to serialize an object with another object. And the third is to serialize an array. In this deserialization test, the first is to deserialize an object with an array. The second is to deserialize an array. The third is deserialize an array with a primitives with a token, and the fourth is to deserialize the array with the primitives without a token, and the fifth is to deserialize an array that has another object. Let's implement them then. In this case, to reduce waiting time, I have some code here, which I'll paste. There's no need to see me type simple things. In the first test, we define the types. Maybe we could encapsulate this for a future refactor. We define the buffers in a string. We define the person object to be serialized. We initialize the objects and configure them with open using their respective buffers. We create the types according to their names, the root object, internal object, and the array. We add the attributes to the internal object. Serialize the array with the object JSON. And add the attributes to the root objects. We add the array to the root object. We get the string and it printed. Then we close. We use the same code to implement the next one, make some adjustments. This time we use the address. The difference here is that there is no array. We use the same code to implement the array test, make some adjustments. Now the array is the main element. To implement, I will add the JSON code we will use as reference for the test. We create the JSON object, initialize it, define a registry with a parent and the two children, and the number of items in the list. I create the mapper for the children, define the types, and register the function to get a list. Then I create a parent rule. In the last definition, I state that there is a rule for the children and pass the map to the children. Finally, I create the root rule with a parent, which has three attributes, passing the parent map and calling the deserialized function. I print the field structure at the end. The remaining tests follow the same logic. I try various forms to ensure this madness works. It is complicated at first glance, but it is straightforward once you get used to it. I have some ideas for improvement, but generally, this is how I work with JSON without worrying about scanning each structure all the time. Going to the compilation, we enable the filter and compile it. We notice some warnings. This is a cast error. It should be a char copy and paste. Compile again, we solve the problem, and we have another issue. The reference is wrong. In this case, it's an array, so it shouldn't have one. Compile again, everything is correct without errors or warnings. I run the test, and everything is fine. I run the test manually, and nothing appears. It is important to call the functions for them to do something. We adjust the functions and run them manually. To see the output. Some were not filled. I tried to identify points to understand what is happening. After some time, I found some strange things. The words are cut off, which is which is a pointer problem. In the deserialize primitives functions, I see that I use the wrong field. I adjust and still have another problem. Then I realize I'm using the wrong JSON inside the serialize items function. Compiling, everything works fine. Phew, that was a long one. But now we have a way to work with the JSON in a simple way. Reduce the complexity to just mapping. This is already better than nesting everything manually, one by one. That's all for now. I appreciate it if you get here. Don't you forget to hit the subscribe button, leave a comment and share. Knowledge is not enough. Waiting for more. Bye. See you soon.